Welcome to our module on backend development using Spring Boot, a powerful framework for modern applications. Here, we will learn to build robust and scalable server-side applications efficiently and effectively. Let's explore the key pillars of the Spring framework that form its foundational strengths. These essential concepts are crucial for developing enterprise-grade Java applications with Spring. First, we have inversion of control, a core principle for managing application components. It effectively manages object lifecycles and their various dependencies within your application. Next, aspect-oriented programming helps modularize cross-cutting concerns in your code. This effectively separates concerns such as logging or security from your main business logic. Spring also provides comprehensive support for data access, making database interactions smooth. It integrates seamlessly with various databases and object relational mapping tools like Hibernate. Transaction management is another vital pillar, ensuring data consistency and reliability. This feature simplifies declarative transaction handling, making your data operations robust. Lastly, Spring offers strong integration support with other technologies and systems. It works well with many third-party libraries, application programming interfaces, and enterprise messaging systems. Now, let's understand the key differences between the Spring framework and Spring Boot. We will examine their distinct advantages to see when to use each for your projects. On one side, we have the traditional Spring framework, which offers great flexibility. It typically requires manual configuration using XML files or Java code. You would also need to deploy your application to an external server like Tomcat. Furthermore, managing dependencies and their setup can be a manual process. On the other hand, Spring Boot focuses on rapid application development and simplicity. Its auto-configuration significantly simplifies the setup process for new projects. Spring Boot conveniently includes embedded servers, eliminating the need for external deployment. It also provides starter dependencies, which streamline project setup and dependency management. Today, we will delve into dependency injection and inversion of control, fundamental Spring concepts. We will explore how Spring efficiently manages the dependencies between various objects in your application. Dependency injection is a design pattern where a class receives its required dependencies from an external source. This means that a class does not create its own dependencies, but rather receives them. By doing so, dependency injection effectively achieves the principle of inversion of control. This approach greatly promotes modularity, making your code easier to test and maintain. Inversion of control means that the framework or container manages object creation. The Spring container takes responsibility for creating and managing your application's objects. As a developer, you delegate the control of object lifecycle management to the framework. This significantly reduces the burden of manual dependency management for you. Let's discuss the various methods available for implementing dependency injection in Spring. We will explore the different ways you can provide dependencies to your classes. Constructor injection is a method where dependencies are supplied through the class constructor. This ensures that all mandatory dependencies are present when an object is created. Setter injection involves providing dependencies through public setter methods after object creation. This method is suitable for optional dependencies that can be changed later. Field injection directly injects dependencies into private class fields. Using annotations, dependencies injected directly into class fields. While convenient, this approach is generally less recommended for testing. Let us look at a practical example of constructor injection to understand its implementation. This method is vital for ensuring that all necessary dependencies are available when an object is created. The add component annotation marks this class as a Spring managed bean for the IOC container. So, the user service class is now recognized and managed by the Spring framework. Here, we see the add component annotation above the user service class definition. Next, let's examine how the constructor is used with add autowired for dependency injection. The user repository is injected directly into the constructor, making it consistently available. The add autowired annotation tells Spring to handle this injection. This code snippet shows the user repository being injected via the constructor, ensuring its presence. Let's explore the key characteristics that define RESTful services for web communication. These principles are crucial for designing effective and scalable web services in modern applications. First, RESTful services emphasize stateless communication between client and server. This means every client request is self-contained and independent of previous requests. The server does not store any client-specific session state between requests. This design choice greatly simplifies server implementation and improves scalability. RESTful services adopt a resource-based approach, focusing on data entities. Each resource, like a user or product, is identified by a unique uniform resource identifier. The design centers around manipulating these data entities rather than actions. This approach facilitates clear and intuitive organization of your application's data. RESTful services leverage standard HTTP methods for performing operations. We use get, post, put, and delete for retrieving, creating, updating, and deleting resources. This adherence to universal web standards ensures broad compatibility and understanding. It leads to predictable and consistent interactions across various platforms and clients. Now, let's outline the structured steps required to build RESTful services using Spring Boot. This structured approach will guide you through creating robust application programming interfaces efficiently. First, you will set up a new Spring Boot project using the Spring Initializer tool. Remember to include Spring Web and Spring Data JPA as necessary dependencies. Next, define your RESTful resource model, typically a POJO class, as an entity. Here, we define the user entity with annotations for database mapping and automatic ID generation. Then, create a repository interface to interact with your database using Spring Data JPA. This user repository extends JPA repository, providing built-in CRUD operations. After that, implement your core business logic within a service layer for better organization. The user service class, marked with add service, uses add autowired to inject the user repository. Finally, develop a REST controller to expose your application programming interface endpoints. This user controller handles incoming HTTP requests, routing them to the appropriate service methods. Let's examine the detailed implementation of a REST controller in Spring Boot. This controller will expose specific API endpoints for managing user data effectively. The add_REST controller annotation marks a class for handling web requests and returning data. The user controller uses add_REST controller to process web requests and deliver JSON or XML responses. Add_request mapping sets the base path. As you can see, the user controller is defined with add_REST controller and the request mapping. Now, let's see how this controller handles HTTP GET requests and POST requests. Add_GET mapping directs HTTP GET requests to the GetAllUsers method, while add_POST mapping handles POST requests for creating new users. This code implements methods to fetch all users and create a new user using add_GET mapping and add_POST mapping. Let's discuss the key benefits of using Spring Boot and dependency injection together. These advantages significantly enhance both the development process and long-term application maintenance. One major benefit is achieving use coupling between different components of your application. This significantly reduces the tight dependencies between various parts of your code. Another advantage is increased reusability of your code components across the application. Individual components can be easily shared and integrated into different parts. Spring Boot and D greatly improve the testability of your application. You can easily mock or replace dependencies during unit testing. Enhanced maintainability is also a significant benefit, simplifying future updates. This makes modifying or updating your code much simpler and less error-prone. Finally, Spring Boot helps create applications that are production-ready from the start. It includes built-in monitoring features and an embedded server for easy deployment. Let's summarize the key concepts we've covered in this module on Spring Boot. These are the essential takeaways you should remember for your backend development journey. Spring Boot streamlines backend development with its powerful auto-configuration and convenient embedded servers. Dependency injection and inversion of control significantly enhance code modularity and testability within applications. RESTful services leverage HTTP methods and resource-based URLs to build scalable APIs. Spring Data. JPA simplifies database CRUD operations, reducing boilerplate code significantly. Spring Security, JWT, and OAuth offer robust solutions for authentication and authorization.